So there, we missed the first part of the video, so I'm going to give you a summary here. So we can change the sine and cosine if we're solving trig equations, fraction math or identities. And again, use your algebra knowledge, especially with factoring. Okay. To solve this trig equation, we use an identity. And now we're down to here. Again, if you can factor, you have to factor. Okay, so keep that in mind. What do I do at this point? Who said something? Nope. Yeah, you got it. Good catch. What should I set this one equal to? Say it. Yeah. Because 0 times anything is 0, right? And what should I set this one equal to? 0 as well. And then solve. So where is sine 0 between 0 and 2 pi?
That would be 0. That would be at 0 degrees and 100 degrees.
How about we're in radians?
That would be 2 pi and pi.
Yeah. Notice 0 and 2 pi are the same thing, right? Same value. But in your interval, they're both included. So you have to include them in your answers. All right. Kellen.
Can you go back to where you factored it? Where do you get the -1?
If you take a sine x out of a sine x, what's left over? So if I distributed this, you get sine squared, 2 sine squared minus sine x, right? So factor versus the hippity-hoppity property. What's sine x equal on this one? Yeah. And that is true when x equals? Okay. Get used to operating in radians. Any questions on that?
No, sir.
That's kind of a medium to medium hard problem, right? All right, let's try one more. Yep.
Okay.
Yep. The book has this in here. For all real values of x, I didn't write it down. That means that we're going to be working in radians. Okay. Radians are our real number system. Okay, is there any way to change this to tangent or that to secant so we can get them related to each other?
Yes, tangent squared plus 1 equals secant squared.
Okay, so and this is squared, right? Nope. Let's translate straight through. Okay. So you see the identity, right? Again, if you see these are different, probably an identity that you need to plug in there. Okay. All right, so we have an eraser. Now we have a pen. Yeah.
Why'd you get
Ugly. What do you think?
Or no, yeah.
What do you want to do when you have squareds and fourths in an equation? What does it need to equal?
one? Negative.
What did it equal in the last one?
So
If you have a nonlinear equation, you always need to set equal to 0. Okay. So we need to plus 1, right? And I'm going to rewrite this. It's an eraser. So that it's, I like to do descending order. So negative tan fourth plus 2 tan squared plus 3 equals 0.
Oh, wow. We can do this. Complete square.
Yuck.
Oh, what's
That's all I
that?
gotta say.
Never mind.
Okay.
Just factor.
Do you like to have negatives in front of your equations that you're gonna factor?
No, sir.
No, I don't. How do I get rid of a negative?
You divide by -1. Yeah.
Okay, so I'm gonna divide each side by, so tan fourth minus 2 tan squared x minus 3 equals a 0 still. Beautiful.
Hey, then you can just.
Now it looks a lot easier to factor, okay? Okay, what are the factors here? It's quadratic, so again, it's quadratic form. If you had that, what are the factors? Well, what makes x to the fourth? Okay. And what makes negative 3? Negative 3, I heard? Plus 1. And do those add up to negative 2? Okay, so translate this into tangents. And then what next? Yeah, set them each equal to 0 because you factored, so we get tan squared x plus 1 equals 0. Tan squared x minus 3 equals 0.
You want radians, right?
Okay, so tan squared equals negative 1, right? Is that possible? You shake your head no, Hannah, why?
You can't take a square root of a negative.
Yeah, it's a squared, it can't be negative, right? So this gives us no solution here. So we don't even worry about it. Tan squared equals. That means that tangent is, somebody said it. That's half, right?
Plus, minus.
There you go. Where's that happen?
That happens.
Unit circle, Katie?
Oh, we just call one. Use one. 150.
No? No? Yes, I know. Elephants in the room. Kirsten, any idea? Again, I told you how I deconstruct these yesterday into a sine and cosine. Where is sine and where is cosine 1/2? So pi over 3. Okay. Where else? There's one more. Should be.
All four of them work with plus or minus?
Yeah, all 4 of them should work. So we get 2 pi over 3. 4 pi over 3. 5 pi over 3. Okay, so because that's plus or minus, we need to consider all the cases there where that happens, positives and negatives. All right, is this all the answers for all real numbers?
No.
No, it's not. Okay, can I possibly write all real numbers here? No, you can't. Suck. It's like rolling a rock uphill for the rest of eternity. Okay, so how am I going to write this so that all real numbers are included?
Isn't it like, you told us this?
Yeah, I have, but it's kind of something we don't practice very much. What do I add to pi over 3 to get 4 pi over 3?
3 pi over 3.
Yeah, pi, right? So those two are represented by pi over 3 plus pi times k. So if you add pi, you get this one. If you add pi again, it circles back around here. And if you add pi, you get this one again. Right, so k is an integer. All right. Now what if I do these two? Are they related the same way?
Yeah.
Yeah.
So 2 pi over 3 plus pi.
Okay, same thing. So you get all real numbers are now covered. Okay. And again, if you didn't see that, we are adding pi, which is 3 pi over 3.
Nifty.
Yep, very. You think you're good, or do you want to see one more? It's the hard one. It's the hard one.
Then yes.
Let's see it.
Yeah.
All right. So this is not something that would be on a test, okay? Because this is your first introduction to this. I would avoid that, but for those of you working at this level, here you go. Oh, I'm not done yet.
Slow down.
Yeah, what I tell you.
Can we?
Easy.
Yeah, this is a pretty obscure
The answer's 6.
algebraic technique. The answer is not 6. The answer is not 42. Thank you very much.
The answer's C.
I want to guess that.
How many terms are there?
1, 2, 3, 4, 5. Oh, you can group.
4, right? Do you remember the factoring methods for 4-term polynomials?
Grouping.
Yeah.
Grouping. This is a grouping factoring problem.
Sweet.
Okay? Because, so look, if you look at it, I have sine in both of these. A cosine will be left, right? And if you look here, I have √3 in both of them. What's left over? Right. So we're probably going to work with grouping. So this group here is factored with what? 2 sine x. What's left? 2 cosine x minus 1. Then we have this group here. What do we take out? √3.
2 cosine x plus 1.
Ooh, they match? You betcha. Okay. Again, the hard part there is recognizing that and executing that factoring. Okay. And then what is our final factorization? We have the same term here, right?
Well, that minus turned into it.
So here's one binomial. Is that subtraction correct? So is it right to have this here? Yeah, but what about this term?
It should be negative.
Do these match? Oh, they don't. Okay. We need to fix that. Now is it right? So if I distribute the hippity-hoppity property,
Wait, and shouldn't it still be negative if you distribute it?
so,
Yeah.
oh, it should still be negative.
Yep.
I was, yep. Okay, so again, checking ourselves, right? Now it's right, yes? Okay, because if I distribute, I still get negative here, and if I negative times the negative is a positive. Okay, good. I'm glad I could confuse you today. You're welcome. Yeah, right? Could you finish that problem now?
Yep.
Emmett, what's our next step?
Combine zeros.
I can't find the words. Don't you say
Well, don't hurt yourself.
Pull that one.
What do I want? Set this equal to what? Yeah.
Oh my God.
And so that means sine x equals,
√3 over 2.
okay? And x equals, where's sine √3 over 2?
In degrees or radians?
I don't think I specified.
You did not.
Oops.
So that.
Choose. Okay. 60? 120. Okay. So where is cosine?
1 over 2.
What he said. Oh,
Where's cosine?
60 and
150.
100.
No. Oh, it's close.
we,
330.
cosine is negative at 120.
330.
Right, so it does have to be 330, if you recall.
300.
You're 300.
Because sine is negative.
Yeah. No.
There you go.
Good correction. Okay. So, there you go. So that one was only hard in recognizing what to do first. Right? The rest of it, not too bad. Do you want me to write the work down again?
So
Yeah, I didn't write it down because it's not due till Friday. Just being lazy. Did anybody start it?
Yeah.
Does anybody have any questions?
Yeah.
Everybody did it.
Not all of it. I mean, like, it was, yeah, one was that I didn't get, and now I'll get them.
Good.
I wrote down sign over 8.
That's what we're doing.
He sat there.
Keep that zero there.
Oh.